Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to my teacher and fellow friends. Today we are from group 5 going to present about our project heat transfer for the PESA project. Okay, we are going to present about the assumption. Here is the assumption and design approach where it will cover the assumption towards physical, costing, thermal properties and also the design. Okay, before we go further, I would like to explain a little bit about this. The design for the dispenser project, we decided to cover only a large surface of the vertical walls. We decided to use the fiberglass as our insulator. The fiberglass is insulations offer a lot of characteristic that can resist is in improving the efficiency of the insulation system. Okay, as you can see here in the slide, there's some advantage from the characteristic that we get. Okay, first one, fiberglass insulation is inexpensive and effective. Okay, for the second one, fiberglass is unaffected by shrinkage. Then fiberglass also to reduce and the risk inhaling the fiber. Most manufacturer deliver the material in seal but coated in plastic film. It is particular propagated polyethylene and polypropylene. Okay, for the next point, fiberglass beds are coated with a plastic that acts as a vapor barrier. And the last one is fiberglass insulation is fireproof. That's only for my part. Thank you. For the next is my partner.
Assalamualaikum, I am Muhammad Wafi bin Mahir with meeting number AD190104 and I will explain on the thermal properties of the project. So basically the thermal resistant network for this project will be in a series of layers, and then the heat convection might be provided from the movement of the gases inside the tank. At the outer layer of the surface, it is assumed that no heat convection since the wall has been painted. The outermost layer that have been painted should provide no condensation. The wall is assumed to have a perfect size of thickness of the insulator. And finally, the value of the heat leakage can be reduced.
For costing assumption, the average of the cost to install the fiberglass is started with 3.87 and 7.22 ringgit Malaysia. The value for the thickness of the insulator must be fit with the minimum heat limit. We can assume that the heat transfer through composite wall is equal to energy transfer through outermost convective layer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhawin Zanizan and my number metric is BD 2084, and I will present about the analysis, viewpoint and also the thermal resistant network. So the viewpoint for our project would be 33.48 Celsius, while here is our thermal resistant network, which is they have a resistant convection at the window of the wall. Next is the analysis thickness insulator. To find the value for the thickness insulator, we need to find the value for the thermal resistance for each layer of the wall. In order to avoid any condensation at outer surface, the limit temperature should be equal to the dew point, which is 3.48 Celsius. And while heat transfer through composite wall should be equal to heat transfer through outmost convective layer, as all the layers are in the series. Therefore, the thickness insulator for this project would be 3.8057 millimeter.
My name is Muhammad Nizat bin Zaini and number matrix DD200084. And I will talk about analysis final design. The size for this project is 6 meter times 2.28 meter times 2.34 meter. And the surface that will cover is only to surface area for 6 meter times 2.28 meter. The requirement for the thickness for every layer is shown as below. This is our calculation for analysis costing, and the average cost we get is 1,133 39.70 to 2,126.31 ringgit.